I know we touched on it slightly earlier, but we are seeing this increasing demand in commercial space exploration, if we can call it that. So, is this now going to be a major driver for helium and the gases industry going into the future?
Well, there's no question that there's a lot of attention on trips into either low Earth orbit or high Earth orbit, or to the moon, or even to Mars. Uh, Systems need to be developed for all of these applications, and that's a lot of work for a lot of engineers. The difference here is that it's not being funded by the government per se. A lot of it's being funded by private industry, by venture capital, by investors who are interested in funding these activities. Many of those investors are looking for some sort of economic payback, which explains why there's a lot of talk about going to the moon for helium-3. But just the pursuit of science, engineering, and technology advances, I think, is another reason to do these things. Increasingly, however, you see an endless number of companies that are launching rockets. You can watch rocket launches from Norway. You can watch them from Canada. You can watch them from Japan. Certainly here in the United States, obviously from Russia, from French Guiana, for the Europeans. This is something that half a century ago, there wasn't hardly anybody launching rockets, and most of them were for military purposes. Today, they're not making rockets for ballistic missiles. They're making them for space exploration, which I think we should all be quite thankful and happy for. Obviously, the more launches that occur, the more industrial gases that are necessary to either manufacture the components. We haven't even talked about that. The need for massive amounts of industrial gases to make the components that go into these rockets. And then there's, of course, the gases that are needed for propellant, for oxidizers and leak testing. All of these things are necessary. There's other specialty gases also involved in this, like xenon, which is used in a Hall effect thruster to send deep space probes into outer space by squirting an ionized jet of xenon out the back of the unit. You wouldn't think that a very small amount of gas being ejected from the back of a probe would work very well, but in fact, just with simple Newtonian math of force equals mass times acceleration, a constant acceleration, no matter how small, ends up adding a tremendous amount of velocity to that unit. And this is how most deep space probes are powered well out beyond the orbits of Earth into deep space. The ones that were launched in the 70s were all launched using these type of technology. And it's amazing how at the speeds at which they can achieve just by squirting a small amount of ionized xenon out the back, or krypton. All of these gases are critically important for the space industry and many other industrial applications. But the more activity in space that is driven by man's desire to explore, the more of these gases will be needed, and the more engineers will be needed in order to design these systems so that they are both useful, efficient, and safe.